Hi, this is Eric Vogelpohl with Blueprint, and as a part of our web series, I want to spend some time today to demystify streaming data services in Azure for BI and analytical workloads. A bit of background for today's discussion. My peers and I at Blueprint are working with many firms, midsize and large, that are perhaps like your firm in an era where they're reimagining and uplifting on-premises BI and analytical workloads up to Azure, building out the modern data estate or the modern data platform for analytics. And a couple pieces of feedback as we work with key stakeholders. One, we're seeing an over reliance on, say, the traditional ETL pattern is really the only mode of data acquisition for the modern data estate. We want to dispel that. And streaming patterns must be considered. It is quite impressive, frankly, this era we're in which we've seen over the last 3 or 4 years or so the rapid maturation of the services that support streaming data patterns. We're in an era now where streaming data services should be and are quickly becoming first party contributors to your modern data estate. So, a couple takeaways as we go through the day. One, let's disassociate streaming and IoT data. Of course, IoT data is perfectly at home in streaming patterns, and there's probably really not an alternative use case for streaming IoT data. But on the flip side, don't dismiss the events that come out of applications or transactions that come out of databases. These records can be streamed as well and incorporated into a streaming pattern, and this is often overlooked. Second takeaway, and this is really a call out maybe to traditional BI leaders or BI pros. Partner with your application development teams. Go find them and ask them what streaming services are in use at your firm. You may find out that ecosystems like Kafka, or perhaps running on prem or in the cloud, or event hubs, probably message queues, but the streaming data services around Kafka and event hubs, they may be in use. And if they are, um, you can leverage them to contribute data to your modern data estate quite easily. We'll talk a little bit more about that when we get to ingestion hubs. Finally, we'll review some services in Azure that are party to streaming data use cases, and we'll do some demos. So for foundational sake, let's review a handful of streaming data providers, and we'll touch on a couple aspects with respect to ingestion or hubs. So I'll highlight the obvious usual suspects with respect to streaming data, and we know them and love them well. Things like web clickstream, and of course, everything emits a log. They may not all need to be brought into a traditional analytic framework, but if they can, these are party to streaming services, as are social events and all the digital exhaust we leave behind in the various social inner tubes. And then, as we talked, IoT data, of course, even traditional SCADA, maybe the pre-IoT era services, measurement, metering from energy or utility firms, again, all party to a streaming pattern, truck fleet telemetry. The list goes on and on. But in contrast to this, let's, again, as I noted before, let's not forget the opportunity to take data that may exist or may be accumulating in a line of business normal transactional system, an Oracle, SQL, DB2, MySQL, etc. These transactions can be plucked out at basically a point of real time and sent downstream in a streaming pattern. Of course, the messages come from a point of sale system, a sale, an event, that can be streamed in and run through some type of machine learning algorithm to look for fraud. Inventory state changes, real time, we get below a threshold, etc. Again, talking about what new behaviors would we see in various lines of business if we were able to deliver insights at effectively their time of creation. And this is a kind of an important one in my opinion. You probably work with several SaaS providers for either service management or ticket management, CRM, HR, customer experience management. There's a ton, of course. And a lot of these SaaS services are digitally native, meaning that they're already built on architectures that are comfortable in streaming patterns. I would encourage you to reach out to your representatives, your tech representatives, and ask them what options are available with tools that we'll get to in just a second that would provide messages either at scale for initial acquisition to some streaming pattern or as they accumulate throughout the day. You need not think of these tools again as just sources ripe for ETL only. So, of course, once we've made the strategic decision that we want to, participate in a streaming pattern, we have to get it to a hub of some sort, and that really represents the first point, at least in Azure, of ingestion. Azure supports two hubs, the Event Hub and the IoT Hub in this context. They're different in the sense that IoT hubs better better fit for devices and telemetry, and there's some bidirectional capabilities and a few other things that make them better fit for IoT workloads. But the Event Hub is the kind of the general purpose, high scale, low latency, quite inexpensive method for acquiring data at very high scales and high speeds. And hubs essentially serve as nothing more than a buffer between the producers of data, perhaps all of these systems, and consumers, and we'll talk about those next. They can produce and consume at different rates, and there certainly isn't an issue here with scale. Um, IoT and or event hubs rather in Azure are compatible with Kafka, the Kafka protocol, and its various APIs. So again, reach out to your app dev teams and ask if there's a partnership between those services in support of real-time ingestion. All right, let's set up our first demo. This will be fun. So here's what we want to do. We want to collect all tweets associated with perhaps your company's product or service, score them for sentiment, and save them for some secondary analytical uses. So here's what we're going to do. I have a script that is continually pulling anything hashtag, in this case Xbox and PS4, once a second or so. And if I find a tweet, I send it to an event hub in this case. So I am a producer. And notice we have an option in event hubs, same with IoT hubs. We have the ability to, without any additional processing whatsoever, if nothing else, we want to just save all messages that roll into the event hub to long-term storage. This feature is called Capture. It's not going to be a part of our workflow, but note that it's out there. So for the simplest form of ingestion in your BI and analytic tools, getting data to the cloud, which is sometimes difficult, a message flowing through a hub can very quickly just be put to long-term storage without any pain and suffering whatsoever. So it really marks a great source of just basic acquisition. Okay, so once messages are delivered to the hub, we're going to pick them up in Azure's Stream Processor, and their Stream Processor is a tool called Stream Analytics. We're going to write a relatively simple job that we'll walk through. We're going to call a function that I have in Azure ML Studio. This could be a function in Azure Databricks or other ML tools, but in this case, I just borrowed an off-the-shelf tweet sentiment function that was nicely fit for Stream Analytics. We will post the tweet, the actual 280 character tweet itself, to the ML Studio, and we'll get back a sentiment score as a record set. And then Stream Analytics, with its input being the hub and its output being 5 or 6 different services, we will stream data to a Power BI real-time dashboard, and we'll do some analysis of those tweets. And then, apart from the capture feature that I noted, we're actually going to reformat that data to JSON format, which makes it very easy for secondary analysis. And we're just going to keep this for long-term storage. All right, let's get started. Okay, so we have a script and it's running and it's sending about once a second a tweet that it finds with the hashtags we're looking for to the event hub. And you can see that every time it finds a tweet, it's just giving me some feedback here that we're successfully sending it to the event hub, so I don't need this anymore. We can set that aside. Okay, so one thing that I like to do in demos when we're using a hub is to help demystify what the hub is doing. Let's actually peer into the hub and see messages go through it. So with that, we're going to use a tool called Visual Studio Code. It's a lightweight development tool. There's an extension that you can download for free, and it gives you the ability to peek into Microsoft's hubs, the IoT hub and the Event Hub, to see packets flowing through it. The Kafka ecosystem has very similar tools that allow you to do the same thing, and there are many, many, many different tools that on GitHub that allow you to peek in and look at messages. I happen to just use this one. So let's go ahead and start the command to monitor the messages flying through the Event Hub. Let's just make certain that it's working. And about every second or so, we should see a new message land, and that message is a tweet. And we are. You can see it's incrementing once a second or so. Let's go ahead and stop this. Let's take a look at the full payload that we're getting from Twitter. Okay, so I've stopped this. The messages are still flying and the hub is still running, of course. We're just not monitoring it anymore. So let's scroll to the top and take a look at how this message is formatted. It's obviously a JSON message. Here's the beginning of the most recent message we saw before we turn the monitor off. And this person has tweeted out. The tweet is, in this case, a column called full text. And there's whatever tweet he or she sent. We have a handful of structures within this JSON packet. We can look at hashtags, for example. We have some information about the user and the various properties about the message and when it was sent and what device and all kinds of fun things. We're going to, take inventory of the columns we're interested in plucking out from the message in the hub in Stream Analytics. So let's jump over to our Stream Analytics workflow. To do that, we're going to go to Azure, and notice I'm in my Stream Analytic job, which I call Azure Stream Analytics, Process, Twitter from Hub. And this is a really simple environment. Again, this is Azure Stream Processor. Stream processors start with an input. In this case, I have an input from my hub, and no code required. I just simply clicked on the hub I was interested in and authorized it, and that was it. And then I have two outputs for the stream processor. I have an output to Blob Store in a format we want, and I have an output to Power BI. I also had to define one function, and the function is the service that runs in ML Studio. In this case, here's the URL, and the key is hidden. I called it ML score tweet sentiment. This is it. The only thing I need to do is pass the tweet to this function, and I will get back both its score and its sentiment. So that was it in terms of behind the scenes setup for Stream Analytics. Again, I have an input, I have a function, and I have two outputs. So let's go ahead and kick the job off, because that takes about 40 seconds or so to start. And while that job is starting, let's take a look at the job itself, the actual query that makes up the job. Give myself a little bit of real estate here, and we'll walk through it. It is very, very simple to understand. The first thing that I need to do is just basically create a function to call the function we have. In this case, I'm just going to say, hey, I want to use that function that we defined in Stream Analytics. I want to pass, there's full text from the actual tweet, from the message that we're getting from Twitter and putting on the hub via the script. I'm going to call that tweet sentiment score. It's going to pass me back a record set that contains both the score and the sentiment. I want a few other columns. I wanted to clean this column up a little bit to see where the tweet was coming from. Okay, so now that we have this little function defined, this will run over and over and over again and perform this iteration over every new message that appears in the hub. And then, of course, from that, I want to select out of that function the columns that I find interesting. In this case, we'll blow open the score and the sentiment itself. I want to send that to Blob Store and want to do the exact same thing, but want to send it to Power BI. And that's essentially it. So if we come back and take a look at our job diagram, we can see a visual representation of what the stream processor is doing. So it's grabbing data from the hub, sending select columns to a service, getting that data back, and then sending it to Blob Store and Power BI, and away it goes. So this little screen here just provides a real-time monitor once the job is up and running to see how data is flowing through just the stream processor. Okay, so the job is now running, and let's do this. Let's make certain that we're actually getting data to Blob Store. So let's jump over to Blob Store, and before I hit refresh, notice I already have a folder here in my social feed container, which is on my Blob Store account, so it's just a different Azure service on that. And notice that we're accumulating data. This is actually not from Azure Stream Analytics. This is part of that capture service I noted earlier from the hub. So I've gone ahead and turned that on. I'm capturing all data, but if I hit refresh here now that our job is running, I should actually see a new folder, and I do. This is the output of Stream Analytic. We're going to send just select number of columns in a very nice JSON format, And you can see here it's partitioned by year, month, day, and hour. And sure enough, there's our file, and it's accumulating every second as the job is running. So let's take a look at it, make certain that we're getting the data out of the service we expect to get. Okay, so we clearly have a JSON document here. It's just flattened in this view for us. We have a column called tweet, and there's the entire tweet. And if we scroll over, we can see the sentiment. In this case, this person's tweet was scored negatively at a score of 0.31. And there's a couple other pieces of information that I wanted to capture: who tweeted it, their name, the number of followers they have, etc. Okay, so at the time of this file's creation, when I opened it, we had processed 79 messages. Let's refresh it. We probably have a handful more, and we do. We're up to 94, and I can refresh it again, and what do we get to 96? So clearly this is running, but this is just storing data off. It's not all that fun. Let's actually jump over to Power BI, because remember, we're sending this to two outputs. So in Power BI, I have a work group assigned for real-time tweets. I have a dashboard, and this dashboard is empty. There's nothing here because I haven't done any work yet. Let's jump over to data sets. And sure enough, we have a data set that just appeared when the ASA job, or the Azure Stream Analytics job, started up. So let's go play with some of this data. And we actually create a real-time dashboard. Okay, we'll give myself a little bit more screen real estate here, but this is Power BI, you've probably seen. And we're going to do just some quick analysis. Let's go ahead and get our sentiment score. Let's say by the date processed. And we'll take a look at this as, like a line chart. And let's go ahead and calculate the average. We don't need to do any math for that. Power BI provides us the analytics pane with some built-in analytics. And we can calculate things like average, min, or max. Let's turn the label on, and we're seeing at this point we've got a sentiment score that's neutral, dead neutral at 0.49, and there's the scale between 0 and 1 that we see. Okay, we'll park that there. Let's also just simply count the number of tweets coming in. Maybe we want that on our board to watch it show up in real time. There's the tweet themselves. We don't care about that. We just simply want to take the count. And we'll turn that into a card of some sort so that it's bright. Okay, and then let's do some quick analysis on the sources that people are using to send data to us. So again, we can just grab source, and we'll just grab tweet again, but instead of displaying the tweet, we'll just simply count the tweet, and this will tell us the number of tweets we have coming in by their source. And to no surprise, smartphones are the biggest contributors of tweets. So let's take a look at that maybe as a bar chart. Okay, so we have a simple analytic here, and we could analyze sentiment by pretty much anything, by user, by location, by other hashtags that they sent. There's just tons and tons of analysis we could do, but in this case we just want to demo the fact that this is running in real time. So let's save this report. We'll call it test real time. We'll hit save, and now that we've saved the report, we can pin these to our real-time dashboard. And by pinning them to the real-time dashboard, we actually invoke the real-time nature of Power BI when looking at these on the dashboard itself. So now that we've pinned all three, let's indeed go to the dashboard. And as long as the Azure Stream Analytics job is running, and as long as we're sending data to the hub, we have a real-time pipeline running literally in real time. In this case, we're scoring data for sentiment, and we're seeing this come in. Now, I want to stress, it may not be a business use case for you to have, desk-bound analysts, for example, literally staring at a screen. This tool may be, or this workload may be better architected as some type of an alert. If key customers alert a negative tweet, maybe we send that message to some customer experience platform or some CRM as something we need to watch out about. True, that may be fair. But in this case, I wanted to show how a very simple pipeline can be plumbed and operate with essentially low code and very, very, very easy configuration. Okay, let's blast through this last demo. Here's what we want to do. We have data streaming in from a turbine, about 20 pieces of sensor data for 3 turbines. It's going to hit an IoT hub as opposed to the event hub that we used the last time. We're going to pick that packet up and analyze it in our stream processor, Stream Analytics. Specifically, we're going to take one value, in this case sensor 3. We're going to look for an anomaly, a spike or a dip anomaly using a function in Stream Analytics. If we find an anomaly, we're going to blast that message off to Event Hub. We're going to pick that message up with Flow, and we're going to tag a Teams channel. Now, in a high-scale IoT solution, we most likely would not use Flow, and we most likely would not use Teams channel, understandably so. We would probably use some industrial-grade function or a sophisticated logic app, and we would target some field service management system, perhaps after looking up the right distribution group, or if there's an individual on call for the night, we would certainly put some sophistication around this solution. But Flow and Teams allow you to see the data coming into the hub. And then, of course, we'll have a cold path. We'll save it to storage. We have an Azure Data Factory job that's going to move it into Azure Data Warehouse every 10 minutes. And we'll pick that data up with Power BI or Excel. All right, here we go. Okay, we're in Visual Studio Code, and let's take a look at the messages flying in from our simulator. We're using the extension provided by Microsoft to look into an IoT hub. So let's go ahead and start the monitor. And sure enough, we see packets flying in, messages flying in. So let's go ahead and stop the monitor and take a look and see what one of these pieces of payload looks like. Yep, typical JSON document. In this case, very simple. I just have all the sensors and their values, and a handful of metadata, particularly the runtime for this engine, its cycle, and then the engine name itself. Okay, so we have data flying through the IoT hub. Let's pick it up with our storage, a real-time processor. In this case, the real-time processor that we're using is Azure Stream Analytics again, and I've called my job Process Turbine Sensor Demo. The job is running. I had my script turned off for a while and restarted it, so you'll see this number kick back up again, and there it goes. Let's take a look and see what this query is actually doing. It's quite simple, just like the one before it. In this case, we are using a function here to call a anomaly detection spike or dip function, and this is built into Stream Analytics. Notice we didn't have to call out to any third-party ML Studio in this case, because we're using the built-in machine learning feature. In this case, the only thing we care about is looking at sensor 3. And I set it to a confidence interval of 90. Actually, it's probably much lower than you would normally use in real life, but I needed to be able to generate enough positive effects to move them onto the hub. So if we find an anomaly, in this case, if the anomaly is 1, here in this where clause, I essentially just want to create a new message and put it onto Event Hub in this case. So we're going from IoT Hub through the processor to Event Hub. And irrespective of whether or not we find a 1, I simply want to save all data. So we're just storing it out to our storage account in JSON format. And that's all this function does. Okay, so we have data now landing into our Event Hub. Let's make certain. So let's go to a different Visual Studio Code window, and sure enough, you can see we have messages flying in, and these should only be tagged as is anomaly, and they are all only is anomaly equal 1. So we can clearly see here that we're getting messages out of Stream Analytics that we want to take down the pipeline for further processing. And for us, our further processing in this case is just using Microsoft Flow. This couldn't be simpler. This is a very simple job. It just simply says when an event makes it to Event Hub, we want to parse that event and pull out the columns we find interesting. And we want to create a message in Teams. And in this case, I just gave it a funny name for the message body. Yikes, checkout, device ID. It's in alert status. This will tell me what turbine it is. And then for the subject, we've given it some extra information that we're getting from the payload. We hit save, and of course, this is a triggered flow, so it runs every time the hub gets a new message from Stream Analytics, it will process an event, in this case to Teams. And as we noted, this is probably not the work stream we would use in an industrial grade solution. We would fire it off to a more meaningful set of endpoints. But this gives you a sense of how simple it is to process messages down a real-time event stream. So let's actually go into Teams, and here's the Teams and the channel that I'm alerting to. And sure enough, it's just a minute ago or so, we had a new event stream in this case for Turbine 124, and there's the rest of the message. So you can see this pipeline is working nicely. Okay, let's switch gears. We'll go to the cold path now. And as I noted, we're just accumulating data first out of Stream Analytics to our storage account. But in addition to that, I wrote a very simple Azure Data Factory job. This Data Factory job runs every 5 minutes, and you can see here it's been running for the last, since I've started the job, since I've started the trigger, 30 minutes or so. And this job is extremely simple. The only thing this pipeline does is it takes data from that storage account where we're accumulating all messages, irrespective of whether or not they're an anomaly, and we simply move it off to Azure DW. We have a very simple mapping here. I think I'm only interested in 6, 7, 8 columns, however many are here. Okay, so to prove that we are landing data into Azure DW, we can just jump over and query. The last time I ran the query, we were at about 340,000 records or so, and that was, I don't know, 10 minutes, 15 minutes ago. So let's rerun this, and we should get a handful more. We do. We're up to 500,000 records, and here's a flavor of the data that you see in the table. Now, at this point, users could connect with any, SQL compatible tool, Excel and Power BI and Tableau and many, many others. Or we could come up with another user interface for streaming data to the end users if they didn't like the Teams approach. And if you have a big data workload you're interested in, note that we are not only saving all data to our storage account, but I also turned on the various capture and forwarding features of hubs. So we also have made certain that we've captured the entire payload coming directly off the hub off to long-term storage as well. So hopefully this gives you a flavor of how to handle real-time data. Hopefully it demystified a few of the services that we have running in Azure. There are many, many, many other patterns we could come up with. These two, I think, serve the purpose of hopefully demystifying it, at least at a beginning level. If you have interest in others, please give me feedback, and thank you for being with me.